In this video, I want to talk to you about the last project of the semester. So we could call it Project 4, I guess, until it's the fourth one, or the project for week 5. Oh, it's got many names, but the bottom line here is that we're comparing parameters in this project. We're going to be comparing means, we're going to be comparing variances, and we're going to be comparing proportions. And that's a bulk of the last part of the class. So let me just jump into it now. As part of the lectures that you've watched, you know that when we go to compare means, when you have small samples, which of course you do in the project, before we can compare means, we need to compare variances. So while in question 1, I want you to do the work to compare the means, you would be remiss if you didn't first compare the variances. So I have page 1 and 2, or question 1 and 2 on the screen at the same time, because in question 2, I just am interested in the variances. That's the point of question 2. So let me slide over here to the right and talk about question 2. I want you to compare the mean sizes or mileages, depending which applies to your data set, for levels 1 and 2. And as always, don't tell me levels 1 and 2. Talk about Mustangs and Camaros. Talk about Tampa and St. Pete homes, or Hillsborough and Pinellas apartments, whatever it happens to be, whatever makes sense for your particular data set. Make sure you use the words. Don't tell me levels 1 and 2. That doesn't make any sense. So in question 2, I want you to give me the null and the alternative for comparing the variances. And I want you to do two-tailed tests, so not equal to variance tests. We've talked about that folded F test. We've talked about the homogeneity, the equality of variances, all that stuff. That's what I want to see here in question 2. So give me the test statistic, the p-value for that test, and then give me the conclusion. I want you to do the variance test at alpha equal 0.10. So give me the words. Don't just say reject or fail to reject. Again, if you want full credit, you got to give me the words of the problem. So talk about the variation in your sizes, the variation in the mileages of your Mustangs and your Camaros. Make the words work. And if you need help, either go see how I'm doing it in the lecture videos and writing the words for that, or talk to the TA or myself, and we'll be happy to help you with the wording of your conclusions. Now in question 1, I really want you to compare the means, but before you know which row, the equal or the unequal row to use in the printout, you got to peek at the variances. If they had large samples, which you don't, but if both samples were 30 or more in question 1, you could just use the unequal row and be done with it. But because you're using small samples, 1 or both, in your case both of the sample sizes are less than 30, you got to consider the relationship of the sample variances. So peek at the p-value on that folded F test, and if it's greater than or equal to 0.1, you use the equal row. If it's less than 0.1, you use the unequal row. And I've talked about that in the video, so I'll refer you back to that. But then once you decide which of your 2 rows is the appropriate one to use, now go in and get the p-value from that row. And then I want a one-tailed test, and you're doing a two-tailed null and alternative. So in part 1 or part A, I want you to specify the null and the alternative for comparing means. You should have mu's here. In question 2, you should have sigma squareds, variances. But in question 1, I want you to show me what the null and the alternative are for comparing the 2 population means. The p-value that you use, you got to take the correct one off of the equal or the unequal row, and that depends on that folded F test. But again, I want a one-tailed p-value. No, you should have to manipulate that, right? You got a two-tailed p-value on the printout. You should know what to do. And then in part C, I want you to tell me what other assumptions do you need. We need random and independent samples. But the 2 considerations here, because of the small samples, you have at least one additional assumption that you need. Depending which row you use, equal or unequal, you may have a second assumption. And again, I want you to write those assumptions in the words of the problem. Just don't tell me random, independent, approximately normal, equal variances, or whatever applies for you. Specify that in the words of your problem. Again, take a look at what I'm doing in the videos. I'll be happy to help if you ask questions in office hours as well. All right, last one, question 3. You don't really have any proportion data, so I created it for you. Proportion of males and females that have a tattoo. I entered the females. 90 of the 300 had a tattoo in the sample. 75 of the 300 males had a tattoo, and we're testing to determine if there's a difference between them. I gave you a two-tailed printout. Use the confidence interval to make a statement about the relationship between these 2 proportions. So look down at the bottom of the page here. That's a 95% confidence interval. Notice the lower endpoint's negative, the upper endpoint's positive. You should be able to give me an interpretation, and it's not going to be a great one in this case, and to take a look at how we compare means, how we compare proportions, It's the signs attached to those endpoints that we really interpret. So see how you do writing that in the words of the problem. Make sure you include that reliability or that confidence level. If I was going to have you do an upper tail test, I want you to state what the rejection region would look like. Now, you know, or you should know rejection regions, and this is material that I started actually last week, but it follows forward here. You know, rejection regions at alpha equal to some number, we reject H naught if. I want you to specify that. You choose your alpha. Anything between 0.01 and 0.10 is fine. You choose a value of alpha, but then go to the appropriate table and find the cutoff point or cutoff points, depends. And I'm asking for an upper tail, a greater than test. So I'm asking really for a one-tailed rejection region. And then the sample size criteria. What did you use? Is this a large sample? And I'll tell you, it is a large sample, but why? What is the criteria you use? And you don't have to actually go through the math. Now, if you're thinking 30 or more, both sample sizes are 30 or more, you're wrong. 30 or more has nothing to do with proportions. There's a different criteria. I want you to tell me what that criteria is. I'm going to tell you that criteria is met. You just specify what the rule is or what the criteria is when you're comparing two population proportions, and simply give that to me in Part C, and that's all I'm asking for. And so a relatively straightforward, usually what I find in a summer class. Remember when I said this is a sprint and not a marathon? The summer moves quick. Usually what I find is that students either do really, really well at the end of the course, or you've just fallen behind and you're really struggling to find a way out. I hope you're in the former group and not the latter. But if you are in the latter, come to our office hours. Talk to us. We'll help you through it. There's videos. Watch the videos. Binge watch my videos. Hey, that sounds like a fun weekend. Anyway, that's project 4 or the project for week 5 or project 4 for week 5, however you want to say it. That's the project that's due. Hopefully this has helped you understand a little bit about what I'm looking for. And hopefully you're working earlier as opposed to later in the week. I will be online. This is due, if I'm not mistaken, it's due June 18th. By midnight, I will be online that night. I'll be online June 18th. Let's see, this is the Stat 2 or Stat 1 class. I'll be online from 7 to 7:30. I will stay later if need be. And I hope to talk to you soon. Good luck.